and welcome to another GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on programming languages. Programming languages can be categorized as low-level languages or high-level languages. Let's take a closer look at what this means. Low-level languages include machine code, which is binary, and assembly language. Machine code is processor specific. This means a command, such as the store command, would have a different binary code on each different type of processor. This means that code needs to be compiled specifically for the processor it's going to run on. Assembly languages use mnemonics to represent commands, such as STO for store and IMP for input. This makes it easier for programmers to be able to write in assembly language than to try and remember the commands in machine code. Low-level languages give very close control over the functioning of the processor. This means that programmers can effectively use them to do anything that the computer is capable of doing. High-level languages use words from natural language, for example, if, while, and for. A program written in a high-level language, which we refer to as source code, must be converted to machine code, sometimes called object code, before the computer can execute it. High-level languages include languages like Python, JavaScript, and C-based languages. Machine code executes quickly because it doesn't need to be translated first. However, it's very difficult to write in machine code compared to a high-level language which uses natural English. Assembly code makes it a little easier to write at low-level languages, but one command in a high-level language may translate to several low-level commands. For instance, the statement num1 equals num1 plus 1 that we might see in a high-level language equates to the three commands load num1, add 1, and store the value as num1 in a low-level language. So it's actually still much easier to write in a high-level language even than writing in assembly code. High-level languages, however, are limited to the existing set of commands. If there isn't a command to do it, then it's not something you can achieve. Translators are used to convert high-level code and assembly code to machine code so that it can be executed by the processor. Assembly code is translated by an assembler. High-level code can be converted either by a compiler or an interpreter. Let's take a closer look at the difference between these two. A compiler takes the source code written in a high-level language and converts it to object code all at once. Object code is machine code that can be executed and run very fast because it requires no further translation. An interpreter translates code one line at a time and executes the translated line of code immediately. So the process is get the next instruction, interpret that instruction, execute that instruction, then get the next instruction, and this cycle continues until all the instructions are complete. There are a number of differences to be aware of between the compiler and the interpreter. First, the source code. With a compiler, you can give out the object code so that the user has no access to the source code. This is good for proprietary software where people don't want the competitors or the user to be able to see the code behind the program. With interpreted code, the source code is visible to the user. Compiled code executes more quickly because it's already translated. Interpreted code is slower because it has to translate the code line by line before it executes it. With compiled code, the whole object code must be stored in memory, so it takes up a lot of space. Interpreted code is executed as it goes, so little space in memory is needed. Compiled code will not be able to be compiled if there are errors in it. You're likely to be shown any syntax errors in a report if you try to compile and it doesn't work. Interpreted code will run up until the error is encountered. This can make it very valuable in trying to debug programs. Compiled code is also optimized so that it runs faster, whereas interpreted code is not optimized. That brings us to the end of this video on programming languages. Join me in the next video when I'll be looking at integrated development environments. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.